Hi guys, we're going to continue on with our Unit 9 classwork packet. Today we're going to be looking at page 14. Once again, Unit 9 classwork packet, page 14, and we're going to start by looking at what's called the law of sines. Now, before we go into exactly what the law of sines is and how to make it work, let's first review what trigonometry has been used for thus far. Thus far, we've used sine, cosine, and tangent, right, with right triangles specifically, in cases where the Pythagorean theorem doesn't work. All right, so when we're dealing with right triangles, Pythagorean theorem's our best bet. Sine, cosine, and tangent are used to find unknown sides when the Pythagorean theorem fails, and we use the inverse trig functions, right, when we're trying to find an angle instead of a side. Now, we're going to look at cases where trigonometry, believe it or not, can be applied to non-right triangles. Let me say that again. When we use sine, cosine, and tangent, normally we're only using them with right triangles. However, there are certain cases where they can be applied as well to non-right triangles, and we're going to take a look at one such case called the law of sines right now. Now, the law of sines can be applied to acute triangles, obtuse triangles, pretty much any kind of triangle, and it's very simple. This is what the law of sines says. It says that if I take the sine of an angle over the side that's across from it, it's going to be equal to the sine of another angle over the side it's across from, and that's going to be the same as the sine of the third angle over the side it's across from. So that right there is the law of sines. Now, this is kind of weird, right? It's like a triple equation. Here's the awesome part. For any of the problems you're dealing with, you're only going to have two. So it's not going to be, it's not going to be a triple equation at all. It's just going to have two, all right? Now, what are you looking for with these problems to set them up? You are specifically looking for an angle-side pair. Let me say that again. You're specifically looking for an angle-side pair. What do I mean by that? Let me draw a very crude example, all right? Let's say that's A and that's A, right? In order to use the law of sines, I need to know an angle, so I need to know at least one angle and its opposite side. If I know that information, I can use the law of sines in order to be able to find another side of the triangle, or in some cases to find another angle. All right? So with that being said, let's take a look at a few examples from your classwork packet. All right? And we're going to start off with a very simple one. We're going to start off, where's a really good place to start? Let's start off with example number 1. Okay? So number 1 looks something like this. All right, let's hope I can draw correctly. There's a triangle, right? Then I've got 12, okay, 71, 35, and let's call that X. Okay, so what I want to do is I want to set up angle-side pairs, right? So I'm going to write the law of sines right here. Sine A over A equals sine B over B, blah, blah, blah. But honestly, I don't really care about letters anymore. I just care about angle-side pairs. So I have an angle here, and I have a side that's across from it. So I'm going to plug that in over here as my first angle-side pair. So sine 35 over 12 equals, now I know an angle, so I'm going to have sine 71. Do I know the other side? No, so I'm going to call that X. Now, for those of you guys who remember Unit 7, there's a little tiny bit of algebra here, right? In Unit 7, we said that to solve a proportional equation, how do we do that? We're going to have to cross multiply. So let's cross multiply here and see what we get. So I'm going to get 12 sine 71 equals X times sine 35. Okay, how do I get rid of a multiplied sine 35, you ask? Well, what's the opposite of multiplying? Divide. So, believe it or not, this whole hot mess over here, 12 sine 71 over sine 35 equals X, that would be my final answer. Now, let's actually take out our handy-dandy calculators, all right, and do some of these decimals. Okay, so I'm going to do sine 71 first. So 71, hit the sine key, I'm going to multiply by 12. Okay, so on top, that's going to give me 11.3462. I think 4 decimals should do it. All right, that should prevent me from getting too off with my rounding. And on the bottom, let's see, what's sine 35? That's going to be 0.5736-ish, all right? Now I'm going to clear everything, and I'm actually going to do that math, divided by 0.5736, and I should end up with something like 19.8 as my final answer, all right? And if you think about it, logically, that actually kind of makes sense, because in a previous unit, we learned that big angles mean big sides, and small angles mean small sides, right? And over here, small, small, big, big. So that kind of makes sense. Let's take a look at another example, all right? This time, let me see. This time, let's take a look at question number 5. Now, number 5 is actually quite easy, all right? There's very, very, very little that's difficult about it, but there's a little tiny first step that you may have to do first, all right? So let's take a look at that. So I have 29 and 103, all right? And then I got x and 15. All right, so I've got at least one angle side pair, right? So I know the 29 and the 15, that's an angle, that's a side, right? And they're across from each other, so I can do sine 29 over 15. Here's the problem, though. This is my side, so this is the angle I gotta use. How do I find that third angle? Well, let's go back to Unit 3. How many degrees are there in a triangle? Silence. Okay, so 180, right? So if I had 29 and 103, I get 132. Let's subtract that from 180 to figure out how many degrees are left for the other angle, and I get 48 degrees. So now I'm actually ready to proceed. So sine 48 over x. And this is going to work exactly the same way. We're going to cross multiply, so I get 15 sine 48 equals x times sine 29. Sorry, I ran out of room there. How do I get rid of the multiplied sine 29? Well, what's the opposite of multiplying? Divide. So I get 15 sine 48 over sine 29 equals x. And again, I can actually go through and I can do this using my calculator. So I'm going to do 48, hit the sine key, times 15. So up top, that's going to give me 11.1472. And on the bottom, let's do sine 29, see what we get. That's going to be 0.4848. And then I'm going to do some division. 1472 divided by 0.4848. Lo and behold, I'm going to get 22.99, and I'm going to round that to 23.0. Okay? So, law of sines, not terribly difficult, right? It's really just about finding angle side pairs, which means an angle and the side that's across from it, and making sure that you guys remember how to cross multiply. All right? So again, angle side pairs, set up two proportions, and cross multiply. Easy peasy.